I'm Anil Kumar. Here is an excellent question which has been taken from test papers. It is based on geometry of circles and squares. The question here is, given a square ABCD with area of 36 meters square and two touching circles, find the length of the tangent segment AT in the given figure. So ABCD is a square whose area is given to us as 36 meters square. So we have area A of 36 meters square. That means each side length is equal to how much? So A to D is equal to square root of 36, which is 6 meters, right? So each side is 6 meters. So this is 6 meters and that is also 6 meters. Now, we have these two circles. The circles are tangent at a point here. What we are going to assume is that if we join the midpoint through the touching point and this vertex, it is a straight line, right? The idea here is that from the center to any point on this circle will be a radius, right? So this is the radius. Radius in this case is going to be 3 units. Since total is 6, so this is 3 units, right, from here to there. Now this straight line should actually get, once we connect this to C, then the radius of the other circle can be A to this point. Let's call this point as P, right? So A to P. Let's call this midpoint as M. So now MP is 3 units, and what PC is, it is the radius of the bigger circle. So what we can do here is that we can connect C with the point T, which is tangent, AT tangent to the circle. Now, in this particular case, that radius, CT, is going to be equal to CP, right? Both are same, correct? So what we need to find is the length CP. Then we have a triangle, a right triangle to work with. A right triangle will be formed by joining A with C. So this diagonal makes right triangle. We know the length of AC also, which can be worked out from the side of 6, 6. And we can then find C to T and A to T, right? I hope the strategy is clear. So let's first begin by finding the length M to C, right? And then we'll direct 3 to get PC, which will be the radius of bigger circle. Okay, so M to C, that is the hypotenuse for the triangle MBC, right? So for this particular triangle, we know that M to C whole square should be equal to MB square plus BC square, or let me write CB square. Okay. Now in this case, MB is 3 and C to B is 6. So we know MC square is equals to 3 square plus 6 square, which is 9 plus 36 or 45, correct? So we know that MC is square root of 45, which is 9 times 5 or 3 square root 5. Clear? So we know what MC is. Now that means PC should be how much? The radius of the bigger circle, PC, should be equal to total length 3 square root 5. Take away 3, right? PC will be MC minus MP. So we can say that PC is, you can take 3 common and write this as square root 5 minus 1, correct? So that becomes the length PC. Now, we know what PC is. So P to C is actually equals to C to T also, and that length is 3 times, square root 5 minus 1, correct? Now, A to C is the diagonal of this square. So let's find what A to C is. We'll calculate A to C here. A to C square will be equals to AB square plus BC square, and that is 6 square plus 6 square, which is A to C square. So A to C is basically equal to 72 square root, right? 36 plus 36, or 6 square root 2. So that's the diagonal, right? Anyway, we know A to C also, which is 6 square root 2. We know C to T. And now we can easily find what is A to T, right? Which we need to figure out. So A to T whole square should be equal to AC square minus CT square. So AC square is 72, which is 72, right? So we can write this as 72 minus CT square. So C to T square is basically square of 3 times square root 5 minus 1 whole square. That is what it is, right? So let's calculate this. 72 minus, 3 square becomes 9, and square root 5 square minus 1 within the bracket will give us 5, minus 2ab means minus 2 square root 5 plus 1, right? So let's open this bracket. We get 72 minus, within bracket, 5 plus 1 is 6, right? So 9 times 6 is 54 minus 18 square root 5. 72 minus 54 means 12 take away 4 is 8, 6 take away 5 is 1, and that minus and minus becomes plus 18 square root 5, right? Well, 18 can be written as 9 square root, 9 times 2, right? So we can actually take here 9 common, and which is this 9 common, and we get 2 plus square root 5, right? Now AT will be equal to square root of all this, which is 9, 2 plus square root 5. Square root of 9 is 3, so I can take 3 outside, and within square root we get 2 plus square root 5. Units will be in meters, right? So we can now write down the answer, which is AT equals to 3 times square root of 2 square root of 5 meters. Okay? So that is how we can actually find the length AT, which is tangent to a bigger circle. I hope the steps are absolutely clear. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.